Good afternoon to all the participants, and thank you for joining us today. I am Aditya Sharma from E2V Cloud's marketing team. E2V Cloud is an Indian-based accelerated cloud computing platform for all your computing needs. We hope you will enjoy this session and learn a lot from it today. Today with us, we have Mr. Ramjee, the India engineer at Fiddler's AI. What Mr. Ramjee is going to talk about today is about the problems that many developers face while deploying machine learning models in production. Mr. Ramji will talk about common challenges faced while deploying machine learning and how to tackle those challenges. You can write your questions in the chat box during the session, and at the end and during the session, Mr. Ramji will answer those questions. With that, let's move to you, sir.
Good afternoon, everyone. Hi, this is Ramji here. I lead the India engineering at Fiddler.ai. For this, I founded a company called Deepblue, which was in MLOPS, and Deepblue got acquired by Fiddler. And been with startups, building different applications, both consumer and enterprise in the last decade and a half, right? And as we move forward with today's session, like quickly, if as a show of hands, if you can kind of help me with how many of you have ML models in production? We can do a quick show of hands. Okay, I can see 3 hands raised. Great. And like, how many of you have ML models which you have, but they are still not in production? Like they have been developed, but you still haven't put them in production. Raise of hands, please. Cool. How many of you actually develop ML models, right? I mean, whether in production or not, that's a different concern, but okay, that's 3 of you. Anyone else? 4. Okay, great. So the reason I'm asking is, oh, I had to lower my hand. Yeah. The reason I'm asking is, as we touch upon the topic of ML models in production, right? We have to understand how ML is different from traditional software, right? And we will spend some time on that. As a ground rule, if any of you have any questions, please feel free to put it on Q&A. I will. I have this thing open where I can look at it, right? So let me start by sharing the screen. Okay. See 2 of these. Okay. Can you see my screen? Screen with
Yes, sir, it is visible.
Cool. Thank you. Thanks, Aditya. Yeah. 1 second. Let me pin the. Cool. So I'll basically walk you through the ML lifecycle and primarily focusing on things that happen in deployment, because that is the topic of the day. But as I see, some of you have models in production, some of you kind of don't have. Some of you have models which you created, but then they are still not in production, right? So we'll talk through the different stages. And as we are talking through this, it would be great if you can post any questions that you have, any challenges that you have in Q&A, right? And all of you would have access to the Q&A or chat. If you can post your questions, I will cover them as we go, or maybe I can interrupt the talk in between and then we can go, right? So broadly, the talk will be structured where we will be spending about 30 to 35 minutes, maybe a little bit more, depending on how the response is, and then we can open up for a wider Q&A. So moving forward, this is one of the tweets that I found some time back, right? Unfortunately, I couldn't find the source of the tweet, but quick raise of hands again. I mean, how many of you relate to this? I saw 3, but again, I don't know what happened. 2, it became 2, right? So, but you see, like many times, this is what we kind of struggle through, right? Which is the first model is probably very fast to create, but then when you start kind of deploying the model, and that is when you will start uncovering a lot of complexity, a lot of things. So let's talk about some of them as we move forward, right? And that is basically what MLOps is, and that's basically why we should care about MLOps, right? Because this is a problem which most of us face, which is we have the model which is created, we know that it solves some business problem or some specific problem that we have, but it's still lying there for months together, weeks together, without actually getting into production, right? Now, little dialing back a bit, we'll see that, like, if you see, this is something that we all know, right? I mean, most of us who are in the field of developing software, we know what software engineering is, we know what DevOps is, we know what machine learning is, right? Now, MLOps is basically a intertwining of all these 3 disciplines, right? Um, Now, moving on, so how we typically write software, right? I mean, earlier it was punch cards. I don't know how many of you are old enough to know or have used punch cards, but these used to be like checkbooks with cards, right? I mean, and you used to kind of punch holes into the card. So those were the very primitive computing infrastructure that were there. And then we advanced to personal computers, to network computers. Then a lot of times, like in the early days, people used to kind of code and then send across patches or the diffs over email, right? So that used to happen. And then we had a centralized version controls like SVN or there was a visual source safe and many other centralized version control systems. Then it's distributed version control started off, which is like Git became a huge tool in this particular space, right? We have others like Mercurial and all, but I mean, Git, I think, is kind of the biggest tool in this space, right? Now, if you look at DevOps, what is DevOps, right? Essentially, we are talking about how we deploy software, right? And if you look at DevOps, there were times, again, I don't know how many of you know, like you kind of push the code directly onto the production server. You go there, edit the changes there, any configuration changes, even code changes which need to be made, which used to be done on the production server. I doubt any of you follow that particular approach today. You would all have a lot more nuanced and sophisticated approaches, right? But even I know even today some companies follow it. So we were there, and then we used to kind of build binaries, share that around. We progressed to that. Then the continuous integration. Then with the cloud in the last 8-10 years took off, and today we have all these things like infrastructure as code, and then you have Docker, Kubernetes, things like GitOps. In our company today, we actually kind of push code to Git, and then the whole pipeline gets triggered, right? Like first the tests run, and all the tests pass, everything is there, it gets deployed onto a different environment. Again, another battery of tests run. All of those, when they pass, these changes are directly then deployed to the production, right? So the moment something is push to Git, all the pipeline activities get started. So that's the DevOps today. I mean, where we are. And if you look at machine learning, right? I mean, so machine learning is how basically we use data plus algorithms or maths or whatever you might want to call to train the models, right? So I like to give the example of a movie, right? I mean, most machine learning models, though there are advanced, many machine learning models are essentially things with memory, right? So if it's like there was a movie called Munna Bhai MBBS a few years back, right? In that the protagonist, when he is asked about anything about Gandhiji, he can answer anything which he has read, right? But if something comes out of syllabus, he cannot. So machine learning is akin to that. You basically have a lot of data, and you kind of model, write models which try to fit patterns in the data, right? And the simplest of the things are around curve fitting, linear regressions. Then you kind of the mid part of 2000s, right? A lot more work has happened on neural networks and macro chains and all, right? And then today, like most of the math of machine learning was invented even as way back as 1950s, right? But what happened was uh, um, over the years, like especially around after 2012, the compute has caught up to basically ensure that we can solve those mathematical problems in a reasonable time, right? In fact, AlexNet is something that came up in 2012 timeframes. Is one of the first ones to use GPU for image classification problems, right? For on neural networks. So since then, there is again a huge uptake of machine learning, and even now we have deep learning, which has taken off as a complete separate stream. And you also have like recently in the last 3 weeks, you would have seen like ChatGPT has taken off like anything, right? So these are all independent disciplines which we were all very familiar with, and they have matured over a long period of time, right? So but when it comes to machine learning models and the deployment and using them in production, there are multiple challenges, right? um, Correct. Yeah, I took that as a I see this question like just to reiterate, like just to read it out. I think ML doesn't remember the data, but rather learn the underlying pattern. If overfitting is not there, please elaborate on that. That's right. So what you see, what I meant is basically you are feeding, and we will cover that, right? I mean, this is one of the challenges that models have when we cover model monitoring. But to answer the question here succinctly, what I meant by that is, if you are trying to give a ML model after it is trained data which it has never seen, completely, when I say mean data which has never seen, like a completely different distribution, it will still probably give you a response, but that would be very, very wrong for that particular data, right? That is what I mean. I mean, uh, like I don't necessarily I'm talking about overfitting or underfitting. Like I'm assuming you have a model which is which works well for the given training data, and within that uh, if you are giving data of similar distribution, it will follow, right? Not exact values. We will see some of it as we move forward, right? So, okay, let me go back. The key challenges, models are blocked before deployment because you don't have the proper infrastructure or the proper processes to do that. Then one of the things which also happens is all these are different teams, and these teams come from very, very different backgrounds. Like data scientists are keen to solve the problem, but they may not be equipped to talk about uh, the performance and so on and so forth, right? The models that they develop maybe pretty good in terms of solving the problem, whether it is classification, regression, or any of those. But those may not be, they may take a lot of time for actually giving the prediction, right? So that, and collaborating, like all these different teams, your operations team, data science team, software engineering, and many times product, right? All of these collaborating and coming up with a proper approach is a challenge. Then tracking, will not go deep into all of that, but manual tracking of the trainings, then reproducibility, right? Because today you gave a set of data and the model gave a pretty specific prediction. Now, at the end of the day, we all understand that these predictions are nothing but probabilities, right? So if you are giving the same set of data tomorrow, the predictions may be slightly different, right? Because we are calculating probabilities and the probabilities might differ a little, right? So reproducibility and provenance become again very key things, right? And unmonitored models, as we said many times, we may not even consider that. We have deployed the models and then we are happy that it is working, but we may not be monitoring it. We will talk more detail about monitoring subsequently, right? So this situation is not new, right? I mean, in fact, I've been in MLOps space in the last 3 years, and I can tell you that what we have seen is that there is a significant change in the understanding, the tooling, the appreciation that this has to be done separately, right? So we've been there. Software in 90s was like this. I mean, if any of you again has seen or read about things, how things were developed in late 80s, early 90s, and all, like it's a very, very different world altogether, right? So we were there, and in all of the other areas that we mentioned, and we will be getting better at MLOps also, right? So there is no cause for concern. Yes, there is a definite cause for us to kind of pay attention, but nothing to worry about. So typical programming, right? I mean, starting of basics, like we have an algorithm, like, and we give a data to it, and we expect an answer. Whereas in machine learning, it works slightly different. You have the answers, you have the data, and then you actually want it to generate the algorithm for you, right? And what exactly does it look like? Like if you look like in production, typically this part is in development, the answers data which give to the model, and in production you basically have the model, you give the data, and then you get the answers, right? So what are the requirements of a ML system that you have? One is reproducibility, right? The system should be able to retrain um, a 9-month-old model, a year-old model within a few percentage difference, right? It shouldn't be like, and like go back and reflect on your own systems, what you have, and how many of you can claim that. Forget about working on between team members, right? Your own code, right? If any of you are still coding on that, like your own code, how reproducible it is if you 3 weeks or 4 weeks after the model is created, right? So reproducibility is very important. Accountable, must be able to trace back from model in production to its provenance, which we just discussed earlier. Collaborative, the systems you should be able to kind of collaborate between different participants, and it should that is very, very key, because you have different people with different backgrounds having different KPIs in the company terminologies, right? Who have to collaborate and deliver on this particular thing. And of course, the continuous thing, right? Which is basically like, can you kind of deploy automatically? Can you kind of monitor these without manual interventions, right? So all of that, these are the key requirements, the 4 requirements, which any of your systems you should probably keep in mind when you are building them, right? Continuous delivery is basically the ability to change, to get changes of all types, whether it's new features, bugs, configurations, whatever, right, into production or into the hands of users safely and quickly, right, and in a sustainable way. So CI/CD is very, 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 very abused word these days, right? But if you kind of look at it, the CD part has two parts. One thing is continuous delivery and deployment, right? In most scenarios, and especially given some of the things may be under regulatory and compliance, some compliance requirements, right? Especially when you are talking about machine learning. So you may not want to deploy continuously, but you should have that ability to deploy. And that's what continuous delivery talks about, right? So moving forward, this is what many of us think what typical ML setup looks like or is required in an ML setup, right? So most of us think like if we put the ML algorithms, the rest of the things will happen, right? I mean, or they are small enough, right? I mean, uh, not warrant specific attention, right? To give you a very specific thing, like I have started off on MLOps in about early 2019s, and at that point in time, many people were completely of this view, right? But things have changed in the last 3 odd years, 3.5 years. So now people realize that actual algorithm development or the model development is only about 15-20% of your time, right? There are many other activities that needs to be done along with or in a particular order to actually deploy your models, right? That becomes pretty important. This was also not something that came up just like that, right? There was an extensive study done by Google on their own projects, and they have published this paper, right? Which is publicly available. So this is the reality, right? And you can't fight the reality. Like the reality is, and this the first tweets also goes along with this, right? You spend only about 15-20% of your time on the building the model. The rest of the time is actually putting up the infrastructure, right? So for many of you some of you who may not be from ML kind of a background, right? You may think like at the end of the day, my data scientist is also writing code and my engineers are also writing code. So what is the big deal? I mean, what I'm deploying in a normal software, I mean, it is the same for machine learning, right? That's the typical approach or a question that many people, especially those who have not worked on ML or who have cursorily looked at any ML thing, they ask, right? So if you look at it, the main difference is data, right? And you have to keep in mind that whatever amount of data that you give to your system and you train on it in production, things may be very different, right? And you would have heard of few scenarios like Amazon retiring their hiring models because they were biased, right? So that's because the kind of data that they gave um, had those biases in it, right? So that is one example. And when in production, when they give, it may actually behave very different. Again, another example is typically a lot of companies, especially banks, right? In the Western countries, they are as a part of the regulatory compliance, they have to kind of reveal to the customer why the particular loan was rejected, right? So if let's say I go and the bank rejects my loan and I ask them why they rejected, they should be able to tell me, right? And when I actually kind of dig deep and then look at it that they have looked at my gender or my race and rejected the loan, that is against the compliance rules and I can sue them, right? So you see here, right? Why am I taking these examples which are very seemingly irrelevant, right? The reason is that you may have the best of the model and all of it, but if the data is of different characteristics from which you have trained your models on, your model will behave very differently. The code did not change. There is not one letter of code that changed, right? But with the change in data, your model response changes, and that is something very different, right? Which is very different from software. What also happens in other things is like we talked about our ability to reproduce and things like that, right? Again, all of these things are again related to data. What is the size of the data you have? Are you working on small amounts of data, large amounts of data? Where is it stored? How do you access them, right? And who has access to it? All of these things come into picture. Like it is not just that I'll feed the data to any data to the model, right? If let's say somebody, you need to have systems which also consider the security of that particular data infrastructure and so on and so forth. So all of these things combined make um, machine learning a very, very different beast from software, even though at a high level it looks like both are code, right? But they aren't. They're very, very different, right? Moving forward, this is in the development. I mean, I'll skip this. Many of you who have work on models, you would know. Like essentially, it's not only you're in production and all. Even when you're developing models, you track what are the runs as you tweak your parameters and so on and so forth, right? It's essential because many times the model that is performing best need not be the one that you want to deploy for various reasons, right? Some reasons can be the time it takes. Some reasons can be the again it related to this question where overfitting, underfitting. It may be very, very working very well in for the data that you gave, but I mean for a general, you want your models to behave in a generic way, right? The quality data is most valuable asset in the whole life cycle. That's correct. Yes. Quality of the data is very, very important. So you can, I mean, this is my very biased observation and experience, right? Yeah, which is basically that you may have a very simple ML model with good quality data, which will work far better than a very sophisticated model with bad data, right? Now, saying that, we may think that we may be able to get quality data in all scenarios, but that isn't possible. Like, take some scenarios. Like I can give you one example, right? A healthcare service company in the US, they deployed a model which sends across an SMS to the users saying that the weather is not good, don't go out, right? I mean, because you may catch cold or you may catch some viral infection. Now, the SMSs went out, but they have no way of knowing whether people acted on that SMS or not, right? Maybe they will see that so that only like normally they get 100 patients a day, but now they, after sending the SMS for the next 3 days, they only got 50 patients. But that doesn't also conclusively prove that people have acted based on looking at the SMS, right? Maybe it is a holiday weekend, maybe there was a match, maybe there was something else because of which people haven't visited the hospital, right? So the point I'm trying is, it's a very valid point you made, that quality data is the most valuable asset. 110% or even 1000%, that's correct. But uh, your your efforts to get quality data may not always be the case, because the underlying problem itself or domain itself is such that you may not get the data, right? Now, so again, this is just a typical thing, right? Like again, looking at it, you normally, and many of the data scientists among you will know that you don't actually just create one model, train on one data set, and then try to deploy, right? You have model one across different data sets. You have a different model, like uh, uh, even model code, right? You may be using different libraries. You may say, I'll use XGBoost, I'll use like GBM, or I will use some kind of a random forest regression, and then try to compare which one works better. So you want to track all of these, and you want to train based on that, right? And once you train and you are good, you, let's say you deploy, that is not again sufficient, because once things change, like this becomes obsolete, and then one second, sorry, these become obsolete, and then you again have to do the trainings and all again, the whole thing, and you need to track all of this, uh, track all of that, and keep it right, so that you can compare when required, right? Like let's say after you deploy, let's say you today you deploy model 6, and for some reason it is working and all, it looks good in your development pipeline. But then when you actually deploy, you realize that it is not actually working very well, right, in production. So you may want to switch back to model 4 or model 5. So it's like, and at that point in time, you should be able to recall all the data that you have in terms of the training, the performance characteristics and all, rather than trying to retrain again, which is like a huge effort again, right? So you need a system, you need some kind of mechanism to store the models, store the data, version the data, right? And associate that this model finally has these parameters and this is the data, and so on and so forth, right? So in summary, this is what a machine learning software looks like, right? A typical software consists only of code, whereas machine learning software consists of data, model, and code. And in code, typically you have business needs or bug fixes that change the code, right? Otherwise, the code will run for eternity. In machine learning, your data, the schema can change, the samplings can change, the velocity at which the data comes can change. In models, the model algorithms may change, right? How many times you are training, all those parameters around that may change. So there is a lot more access of changes that can happen. Now, moving forward, like this is a typical machine learning life cycle that you see. So the thing that I want to stress is, again, if you see even in the process, in the life cycle, right, the creating of the models is only a small aspect. And to somebody's question earlier, like if you look at it, defining the problem, defining the data, these are the most critical pieces that needs to be done, right? So if you see, these are both H's. If you get this wrong, then in terms of the rest of the stuff, you may be able to implement a fantastic technical system, right? But then that doesn't solve anything for you, right? So without going, this is typical model lifecycle. I mean, if you look at it, you first define the problem, you define the data, and then you create your production systems. You implement the systems, you test that, and deploy and monitor, right? So out of these, the heavy domain dependency is the definitions. And if you see, the domain dependency is pretty low in the actual engineering systems, which is production system design, the implementation, and the deploy, right? So one needs to keep these things in mind when they are kind of creating the creating the project, and they are bootstrapping the team or bringing the team together to solve specific problems for themselves. I'll move forward. This is basically like a small checklist, I can say, based on the maturity. Again, I have seen many teams where they start off with shooting for the sky on day one, where they probably take like, I have 1 terabyte of data set, let me start off, and then let me try to kind of use deep learning, let me try to use some RNN networks and this, that, and then they say like, okay, it is not working for us, right? The thing is, you also have to understand as an organization where your maturity is, whether you're entry level, you have an intermediate maturity and advanced. And based on that, and the maturity is not just a maturity in skill set. The maturity is also in terms of what kind of data you have, what kind of ability to handle the data you have, what kind of systems do you have. So you may have the best of the data scientists, right? But if you don't have proper data, you are still lying in the entry level. You will never be able to consider intermediate level and all. Like, so you need to be able to kind of build the systems to have proper data, then you move to the next level, right? So without that, if you try to do anything, that will probably not be very fruitful, right? Now, moving, see, this is typically we are now getting into the deployment side of things, right? Like as you have the data scientists are working on the model building, they have the training code, they take the data from which the typical data engineers give, and then they do all the modeling. They have a model which they give to the ML engineers who are responsible for, or the software engineers, right, who are responsible for using this model and the appropriate code in the production, right? So typical roles, which are required, and how these roles interact with each other, right? This is probably the most critical piece, like in the thing, right? When you kind of deploy your models, like all the steps that you take in training also have to be done in production, right? In your training, you would have taken the data, cleaned the data, and that clean data, you would have generated features out of the data, and you would have used those features to train the model, right? So in your production also, to the model, you have to give all the data which is transformed, right? You cannot say that I have data, this is coming, and I'll give this data, the model should work. It doesn't work that way, right? You have to take the model through all the same steps that you have done in take the data through all the same steps that you have done during the training period, right? Which is, you are preparing the data, then you are feature engineering, and then that data is what you are passing to the model serving, which model serving, right? And along that, you are also doing you need to do performance monitoring, because if you are not monitoring for the performance, you have absolutely no idea what is going on, right? We'll talk more about that particular slide and the slide of deployment subsequently. Very high level overview. This is something that I created based in this very high level overview of the various components. You would typically have a front end. This is for running the thing, right? Like, and most of the architectural components will look similar, right? You have data ingestion, data analysis, data validation, transformation, right? Whether it is training or trainer tuning the thing. So and then you serve, you log all the things, and you kind of measure the stuff, right? So very high level overview of that. And now let's get to deployment, right? Sorry, development. In development, you start with your data, break it into training and test sets. You kind of have the training and validation set, and you create model M1, M2, M3 on top of these, and then you compare that with the test set, and finally choose between those models, right? So that is what you would probably deploy. A much more detailed workflow, which also looks at the data, right? Now, if you notice, one of the things here, this is not a single block, right? There is a shadow that I mentioned here. Here also you can see a shadow. Here also you can see a shadow, right? Essentially, what that means is there can be different versions of that. So you can have a different version of code. You can have different versions of candidate models. You can have different versions of training data. So depending on how this, like once you have these, basically the various models which are generated based on the training code and the training data, that is when you put them up for evaluation, right? And once you do that, you will choose one of the models, and this is what you put in production. Productionize, sorry, not in production, right? So what do I mean by productionize? I was telling earlier, like there are situations where the data scientists have probably done this and come up with the model, but then they have used R, let's say, right? But all your production infrastructure is in Java. So how do you do that? Like you cannot put the R model in Java, right? So you will have to rewrite or write the equivalent of the Java with that R model in Java, right? So you need to do the productionize. In many cases, especially if you are using like a Python language like Python on both the sides, this may not be necessary. But the moment you switch out of Python and use other languages, this becomes very critical, right? And then of course you need to test and deploy and monitor and observe, right? So let's talk about a model deployment, I mean, which is the crux of today's this thing. So in model deployment, like you can deploy the models in different modes, right? One is embedded architecture, where we'll see each of them in detail. The embedded architecture, where the model is packed with the application itself. So one very common example that we know of is Google Keyboard, right? I mean, where you have the auto suggest and all. So the models are initially downloaded and kept on the local device, and as and when you are typing, the model is actually responding there, right? Then dedicated model APIs. So you have model APIs where uh, like you call them for inference or prediction, and then you do that. So the other is model as published data and offline and batch predictions, right? This is the third one, essentially is like around streaming data, right? So these are the four common different ways in which models are deployed. Now, one of the challenges that many of you have faced, or it is very daunting when you are considering model deployment, right? Is like the moment you start looking at various frameworks, even within Python, right? You have scikit-learn, you have PyTorch, you have XGBoost, you have LightGBM, you have TensorFlow, and you have 100 other frameworks like that, right? Now, unfortunately, the thing is, for serving each of them, it will be very, very different. So there is additional added complexity where, depending on the framework, even for a given language that you choose, and irrespective of the kind of deployment modes that you are choosing, there are challenges there, right? I mean, because of the wide variety of frameworks available, and there is no consistent way, unfortunately, right? I mean, but what happened also is, like, in the last few years, there are a few companies. Many of you may have heard of Selden. Like, you have Selden, and recently in the last year, there's another company called Bento ML. So all of these have come up, and they basically solve for this thing, right? Like, Bento, they basically provide a more consistent interface so that they can abstract away all the variations that I'm talking about, right? So a typical architecture, basically including the training and prediction pipelines. So in the training, you have data. Assume this is the clean data that you got. Then you have the feature extraction, where you are creating the features and all. And this is a feature store. Again, feature stores were not very common until about 2017, 18, right? But after that, they have picked up a lot. And now you see that there are multiple companies working on feature stores. Okay, so you have a feature store, and then you have the model repository, where again, the idea is, like, once you train the thing, you're storing your models, or you are storing different versions of the same model, you're storing different models, doing different jobs, so that you have the complete details of it over here, right? And in production, what happens is, when when there is this prediction service which gets the request, now this prediction service will pick the model from the repository. It will also have some access to metadata service to know which model, where it lies, and all of that. And it also will pick up from the feature store, where which accesses the feature store, right? So the features are coming from here, the model is coming from here, the input is here, right? It does the prediction, and the response goes out, right? So a lot of this job now, I mean, for different kinds of frameworks and all, is what I was telling is done by Bento ML or Selden and all, right? In fact, another interesting way of deploying models and all is Streamlit. I have this here. Streamlit has a gallery of lots of applications. You can just search for Streamlit. You can actually use any kind of an application. Like, you can deploy that. It's basically written in Python, so that if you want to develop a particular UI and all, it kind of can help you, right? Not just because, again, you have the model, but you don't know what to do with it because you don't have the complete infrastructure and all, right? So this is really helpful there. Yeah. So moving on, let me see. This is not loading. I don't know what happened, but it's a nice. Let me see if it loads. Okay, something seems to be off here, but it generates the UI and all the parameters that the model takes are as different controls, whether it's a text box, drop down, radio button, so on and so forth, right? going back, so this is typical architecture that you would find, right? And of course, monitoring service, right? So if you see the embedded architecture that I talked about, like your Google keyboard or any of the applications, mostly if there is an AI component embedded along with it, essentially this is used for also for IoT kind of in environment, right? Where many of these devices are, many of the models are actually deployed on the device itself. Now, the constraints with that is depending on the kind of model that we are talking about, how big it is. Like if you are like talking about an edge device at like an IoT, you may not even have a few KB of space. Forget about MBs and all, right? So here, the flexibility of what kind of size of model and all, that becomes much more smaller. But it's very easy to create and deploy because you are not kind of worrying about creating a server, client, and all of that, right? Which we will see in the next few things. Your infrastructure requirements are very limited. So you basically like have embedded that in your application and you ship it, right? Now the other challenges will be update. If only the model updates because something was different. So how do you know? All of those becomes challenges, right? So the pros are very low latency and pretty easy to build, but the cons include literally almost no flexibility at all for upgrading, for making any changes, for scaling, right? I mean, if let's say you want to scale, so again you will suffer, like you'll have to scale that single application, even if your model requires so only the model needs to scale, right? Let's say the application is only getting about 100 visitors a day, but then your model occupies some 30 GB of space, right? So you basically have embedded it as one. So and if 10 people are using it, multiply by that for the infrastructure, right? So these are the things that needs to be kept in mind when you are looking at an embedded architecture for your serving your models, right? The other one all of us are very familiar with, which is like having it as an API, right? You kind of wrap an API on top of your model and expose that. You have the application which calls the API. Now, if let's say you are working on some of the deep learning stuff where the model is uh, some kind of computer vision and the model is like a few GBs, right? Even if let's say you are only getting fewer hits for that particular API endpoint, you still need a larger infrastructure to serve it, right? So in this kind of a deployment, you can actually separate it off. And when you are doing the model service as a dedicated service, you may wrap it in like if you are using Python, you may wrap it as a Python Flask API, or you can wrap it as um, uh, a Django API, Fast API, any of those, right? Otherwise, I just mentioned earlier about Selden and Bento ML, so you can just actually use them and deploy the model service. And the application, as we just discussed, it can be anything: web application, mobile application, any of those, right? The third approach to deploying is basically something called published data. Essentially, what you are doing is you are also saying like, okay, I have my model. I kind of publish all the various models and the versions of the models and all to a platform. And at runtime, I decide which particular model version or model to choose and appropriately process it. Again, the if you have noticed from 1, 2, 3, the infrastructure complexity has increased immensely, right? But what it also helps you with is it gives you a lot more flexibility and it supports a lot of different workflows which wouldn't happen otherwise, right? So just I think there is something wrong. Sorry about it. Like yeah, I should have one more thing, which is basically batch predictions. Like I don't have the slide. Looks like so. It's basically batch predictions. In batch predictions, you basically are talking about um, offline predictions. Bulk of the predictions can happen at once, but of course, the by definition, batch predictions don't happen real time, right? So if you see, all these are pre-trained. Batch cannot do on-the-fly predictions. Now, the latency of the predictions are pretty high in batch, and it is low in the other approaches, right? And if you see the system management, like again, embedded and APIs are probably better to manage, whereas models published as data is very, very hard. Offline predictions is again pretty easy to manage, right? So this is basically the various deployment modes, the advantage, the the, the good and the bad of each of those models, right? And yeah, model serving I mentioned. One of the things when we talk about deployment, we also should keep in mind is around monitoring, right? So if you see, monitoring is very, very, very important because you deployed the model, and if I'm looking at something like software, I know whether if the if let's say we are using Zoom, right? Let's take the case. If Zoom is not working, you know, I know, right? I mean, because suddenly everything stops and there is nothing that works, right? But it is not, there is nothing like Zoom works, but it is not working and stuff like that, right? It either works or it doesn't work, right? So if you see, typically in a normal software, we care about the service health and uptime, and you have multiple tools like Datadogs, Sentry, New Relic, Nagios, Sensu, various other tools which does the service health and uptime, right? But then if you look at the model and data health, there is nothing in the traditional applications. And this should also give you a comparison with how software is different from any of the machine learning applications. In software, you are only worried about these two, right? You are not worried about anything else. In machine learning, you have so many other things to worry about, right? One of them, like to the anonymous question earlier, like data quality and integrity, right? You have a type mismatch, you have some missing columns, you have missing data, it can be anything. Like you have it as an integer column, but then you got string values, right? Or it sometimes so happens, I have seen a case where all the columns are null, right? I mean, sorry, all the rows in a given column are null, right? So something is wrong with it, right? I mean, or some columns come missing. There will be extra columns which come, or the naming convention of the columns was very different. So there is a whole issues around data quality and integrity which needs to be monitored, because your model may still give you a value, but it may not be very useful, right? So this is data drift. What is data drift? Data drift is over a period of time, the distribution of the model changes. So you, let's say today, when you trained your model, you are only getting S1, but as you kind of put it in production, you are also getting S1 and S2. That's the kind of data you are getting. And then over a period of time, you don't get S1 at all. You got S2 only. So your model was trained on S1, right? So it has never actually looked at S2, and it has no idea how to behave when S2 comes, right? So what happens here? With over a period of time, like let's say over a period of 2 weeks, 3 weeks, you deployed a model trained on S1 data, but you find that 3 weeks later there is no S1 coming at all, and it's a complete thing, different, right? Now, what does this actually mean, right? It essentially means that if you it's essentially the data in terms of, you can't go and sit and compare every input that is coming, right? You are getting thousands or millions of entries, so there is no way you can compare in each of the inputs, right? So that is where you kind of employ the statistical techniques, where here we are talking about the data distribution, right? So if you see, this is the distribution, the light blue is the distribution that the model was trained on, whereas now it is seeing a different distribution. So how can you be confident? And this goes back again to the first question, right? I mean, you have trained your model on this, right? And for that kind of a distribution, your model works fine, right? I mean, it works very well, and maybe it can handle some variations, right? Like here, the mean has increased, so maybe a few percentage points in increase of mean and all, it is able to handle, right? But can your model handle this kind of a change in the input data, right? If the input data distribution changes like this, can it handle? Now, if you are not measuring this in production, how do you even know that your model is behaving properly? You don't, right? So that is the reason why you need to measure drift, especially. Then you have the concept drift. What we talked about, feature drift is input, concept drift is an output, right? So lockdown happened, suddenly new behaviors came, right? And your model doesn't even know those behaviors. So when you trained your model, let's say you said 1 and 2 are the possible outputs, but now suddenly you notice that 3, 4, 5, 6 also are possible, right? So this is basically again feasible, especially when some events happen. One of them recently, if you can see, COVID was one, then the Ukraine war is the other, and so on and so forth, right? So you need some kind of an interface, some kind of tooling to be able to monitor the things that are happening, right? So if you see this and this, like in fact, all the three, there is a drift, and you can see that the distributions are different. There are different algorithms to measure the drift, but essentially you are still, all of them are trying to figure out what is the change in the distribution, right? And then the performance, essentially, like you may actually have started off when you're training at a particular set of error values, right? But then in production, when you start measuring, you realize that you don't have the performance has degraded because the error value has increased, or it has kind of yeah, error value has increased, right? That is one thing. Now, or accuracy has decreased for binary models and all, right? Now, the challenge with something like measuring model performance is measuring model performance requires you to have the ground truth, right? Like, let's say you predicted something, but then actual what happened is very different, right? And I can tell you, like in real life, many times you won't find the ground truth. So when you don't have ground truth, things become very wonky, right? Now, also you are also like there are different metrics, right? Like here itself you can see different metrics. You have ME, then you have MAE, MAPI, then there are many other RMSC, MSC, and so on and so forth, right? Various other kinds of things. Which ones do you choose, right? Because it may be performing very well on one particular thing, but it may be performing very badly on a different metric, right? So which ones do you choose is also very critical, and what you choose is dependent on different aspects, right? So that is one. And so different aspects, like what kind of model, what kind of data distribution. So we call something called unbalanced data, right? So think of it, let's say you have you gave a data where 99.9% of transactions are good transactions, only 0.01% are false transactions, right? And you train your model. The model will not learn anything. It will just keep on saying always that this is a classic example of overfitting, right? Like it will just learn that every time I say this is not fraud, I'm always better, right? So it's a very unbalanced data set, right? So you need to pick your metrics based on multiple things: what domain you're operating, what is the kind of data set you have, and all of that. And the other thing is by segment, right? Very classic example, like last year when second wave came, by end of July or so, the cases across India were decreasing, right? But if you see, from about 250,000, they came down to about 70,000, right, per day. But if you look at a little bit more detail, you realize that um, Kerala and Maharashtra were increasing a lot, whereas other states it wasn't so much, right? So other states, so basically it is the kind of this thing, right? If you look at the segment of Kerala or Maharashtra, they were doing very bad. In fact, their cases are increasing, whereas the rest of the country was doing very good. So this also comes into picture. So you need to monitor at a segment level also, right? Now, all these are challenges that you have, and that's where the monitoring tools come in, which you need to kind of have. So typically, like if you have a static model over a period of time, your performance will decrease, the model quality. If you keep refreshing it based on these inputs, it can go better, right? Sorry, I think I went a little quite some extra time on this, but yeah, this is what I have in terms of deployment, and what are the challenges that you have there, and how you can think about it.
Thank you, sir. Thank you. It was a very insightful session. Now, if anyone in the audience have any question, they can write their question in the Q&A session and in the Q&A section, and sir will answer those questions.
Yeah, any questions, please let me know. Q&A or chat. Yeah, Q&A should be good. Yeah. Is MLOps to be incorporated by ML engineers or a separate role? That's a good question. It's there is no MLOps separate role, right? It is a combination of your DevOps plus data science plus ML. Depending on the size of the company, like at a if you look at a very size and maturity also, right? If you have like lots of models, you will need somebody to be looking at the operations on a daily basis or even hourly basis, right? Whereas if you don't have too many models and all, it doesn't require any special people. Between DevOps and ML engineer, you can manage that, right? So it depends on two things. One is your maturity of using the ML systems in your company. Second, your company organization size also, right? Large companies may choose to, even if their usage is smaller, they may choose to have a dedicated person. Smaller companies, it typically is a overlap of ML engineers and DevOps. How do we measure if the performance of a deployed model is deteriorating? Okay, let me take that question first, and then I'll answer the other one. It's by Kiran. So Kiran, the thing is, even for deep learning, you have these tools. In fact, the company that I work with called Fiddler, we work in the model monitoring space, right? So what we do is we ingest the data that you are giving, and then we monitor those, right? So precisely what I said in terms of the implementation, what will happen is you think of it, you are giving for a moment, you are giving a company or you have an open source tool, right? So that tool, you also give your model details, and then you keep you also tell them what your training data set was, and then you kind of send across all the production data, and they will be running whatever algorithms they run to figure out whether the performance is going good or bad, and they will give you the kind of charts that I was just showing a little earlier. Let me just share that again. So this kind of thing, right? Like essentially, one second, where is that? Yeah, you will probably see it features and all. Now, deep learning, it becomes challenging because in structured data, you can talk about columns and all of it. Whereas in NLP, the moment you go, the visualizations are very different. You can't put them in a table and then visualize. So you typically would probably look at a cluster or of let's say, I'm not as familiar with NLP stuff, but essentially you are looking at the different tokens and cluster of tokens and how those clusters have changed over a period of time and so on and so forth, right? And similar thing with computer vision. Computer vision monitoring is still in nascent stages, not just with Fiddler, but even outside. It is still not very established. It's still in nascent stages. There are different algorithms. Even we have published patented one of the algorithms, right? But yeah, it's so there. What happens is you take the vector representation of the image, and then you kind of measure the drift on the vector representations, right? Hope that answers the question, Kiran. Somebody asked, how can we scale the deployment if we are using Kubernetes cluster for deployment, given we have around 10 ML models that need to run in parallel? So each model service, we have a very similar scenario, right? I mean, the customers provide us their models, and they can be providing any number of models, right? So in Kubernetes, like each model, like what we follow, again, there can be different ways, because there is a trade-off between cost and flexibility, right? But what we do is every model is a separate service, right? And that service can scale independently of others. I mean, and you are on Kubernetes, so anyway, you would just have to have the service configuration and the deployment configuration so that it can scale up and down. But again, there is a lot more nuance. It is not as simple as I mentioned, because the nuance comes from, are we talking about what is the size of the model? Like if you're talking about some of the computer vision models which are in 30, 40 GB, like every time the pod comes up, do you want to load that or not? So all of that also comes into picture. So there is no like, okay, you do this, it will scale. It depends. Like if it is a small scikit-learn model which I can just ship it across, there is no problem at all, right? I mean, it's like a few MB, and you can download that into the pod and deploy it. And you can scale the number of pods like by applying the appropriate factor, right? But things get challenging when you have dependencies, where you have the data, how we are going to give the data. So all of that comes into picture. Like let's say if you are trying to run kind of a batch kind of a prediction where you are giving GBs of data and to a Kubernetes system, which may not be ideal, but I have seen again systems like that, right? So it may get a little tricky, right? What the role of cloud in doing MLOps? How can a cloud provider help its customers to do MLOps easily, right? So pretty much, right? I mean, if you see, like we just spoke about in the earlier question, like Kubernetes clusters, right? And I'm sure E2E as a cloud provider, they also, if I understand, have some kind of a, let's say, managed Kubernetes environment. So that itself is half of your headache solved, right? I understand other cloud providers also provide a similar thing, right? That's one way of looking at it. Then the cloud providers can also provide things around training and deployment and all of that, right? Those particular tools. And if you look at it, there is a popular thing called Kubeflow, which is basically built on Kubernetes, which is cloud agnostic, right? It's a little hard to set up, but you have Kubeflow, and maybe the cloud providers can provide some of these as part of their offering, right? Like a managed Kubeflow, just like how I managed Kubernetes, can really ease out the effort that the company has to put in, right? So hypothetically, again, I don't know if E2E does it, but let's say I have come to E2E, and then they have a managed Kubernetes environment. They also have a managed Kubeflow, so I don't need to worry about anything else. I can just get started off with that particular like training and deployment. Now I know that some cloud providers also provide monitoring capabilities, but my experience has been monitoring is a lot more nuanced. It's not a general infrastructure. It is not like a Datadog or where the metrics are very standardized, right? I just spoke about some of the challenges in monitoring. So what I noticed is monitoring is done better by specific companies than general cloud providers, but deployment and training are very much ripe for to be provided where they can provide these features. Okay, the other one, few models are loaded in Triton server and few are CV models deployed in the prod. The input will be videos. So I'm assuming this is for the Kubernetes cluster. Yeah, so as I said, the simplest architecture can be every model one service, right? So that it can scale parallelly and by itself, right? Uh, without any pathology from other models running in the same pod and all of it. But because of cost reasons, because of other such reasons, because this can quickly escalate, right? Cost. One of the things that we have done is we have multiple virtual environments running on the same pod, and we have like three or four. We basically, like, based on the request, we load the models, right? And when we do that, the challenge that we faced is there is a latency, right? Because let's say currently model 1 is loaded and the request has come from model 2. So the model 2 has to be loaded and it takes a little bit of time, right? So which again has to be considered, whether it is okay or not okay with that kind of latencies, right? Now, saying that, I don't have a lot of experience with trying like complex setups with computer vision models. We have done some things on Lambda and all, but those are like generally AWS Lambda, by the way, you can use to uh, deploy models, right? And we have also used Fargate, but those are like much smaller in size, like a couple of GB and not more. I don't know what kind of size of CV models you have, because I have heard from my other co-practitioners in this space that they have like multiple GB of models there, right? So I'm not very sure how it works in such scenarios.
Thank you, sir. Thank you. I think
Yeah, thanks, Aditya. Thank you all. Pretty much.
yes. Thanks to everyone for attending. And thank you so much for sharing your thoughts and knowledge. I hope everyone had an excellent time and is leaving with some valuable insights. Let me just tell you that NVIDIA A100 is available on E2E Cloud and you can contact us for your free trial. E2E Cloud will be having another webinar on machine learning deployment strategies on 5th of January, and invites will be sent to all of you, and we hope to see you there. Thank you for joining. Have a nice day ahead.